All right, so using the binomial theorem and Pascal's triangle, I'm going to show you how to do a binomial expansion of a high degree. So the first type of binomial I want to look at here is very basic, x plus 1. I want to raise it to a power of 5. So before you expand here, just keep in mind a few things here. So first of all, ask yourself how many terms are actually in this expansion. Now, remember, it's one more than the actual exponent, which I'll call n. So we have an exponent of 5. Therefore, the number of terms obtained should be one more than that. So we should have 6 terms all in all when we expand. And then second of all, which row of Pascal's triangle will this correspond to? And the row is actually equal to the number of terms. So this is going to correspond to row 6 of Pascal's triangle. So here's a nice little table method to do a binomial expansion. You don't have to do it this way, but it's just one way of showing it. It just kind of organizes the information a little bit better here because expansions can get a little bit messy. So first of all, what are the coefficients? That's the first thing you want to find out here. So the coefficients are obtained from Pascal's triangle, more specifically row 6. So row 6 is 5, choose 0, 5, choose 1, 5, choose 2, 5, choose 3, and 5, choose 4, all the way down to 5, choose 5. And you'll notice there's 1, 2, 3, 4, 5, 6 terms, which coincides in what I just talked about here. So what are these actual numbers here? So if we're looking at row 6 here, we're going to get 1, 5, 10, 10, and 5, and 1. All right, so you could use Pascal's triangle to find out those numbers, or you can actually calculate them yourself. Let's go to the x terms. So the x terms are the first terms. Okay, so the first term of the binomial. So the first term of the binomial is x. So that's nice and easy. So we have x all the way down to 6 different x's. All right, and now let's talk about the powers of x. Now, the powers of x, remember, they decrease by 1. So decrease by 1 starting with 5. So 5, 4, 3, 2, 1, and 0. Okay, so you're starting with actual n here. So n is the expansion number. Let's go to the y term, which is the second term of the binomial. So the second term of the binomial is simply just 1. So the y terms, remember, x terms decrease by 1, y terms go ahead and increase by 1. So we start with 1 to the power of 0, 1 to the power of 1, 1 to the power of 2, 1 to the power of 3, 1 to the power of 4, and all the way down to 1 to the power of 5. All right, so I'm going to put all these together here. Eventually, I actually want to evaluate these numbers first. So 1 to the power of 0 gives you 1, 1, 1. These are all 1. All right, so here we go. So let's find out what the terms are. So the first term is obtained by multiplying 1 times x to the power of 5 times 1, which gives you x to the power of 5. Same thing for the second term. 5 times x to the power of 4 times 1. So 5x 4. Let's keep going here. 10 times x cubed just gives you 10x cubed times 1. I won't write the 1. Same thing here, 10x to the power of 2 this time, and then 5x, and then we have at the very bottom 1 times, this is actually 1 times 1, which will give you 1. All right, so here are the terms of my expansion. So to write down the final expansion here, we can finish it off. X plus 1 to the power of 5 is x to the power of 5 plus 5x to the power of 4 plus 10x cubed plus 10x squared plus 5x plus 1.